Hello again, year 10 triples. This is the video accompanying your fact book section for week 3 lesson 2. So that's the second lesson of the week, commencing the 22nd of June, and this should be your second lesson. This is looking at rate of reaction. I've put on the screen at the moment the key facts that we're going to be covering to do with rate of reaction, and the points that we need to get through. Okay, as previously, for some reason I've started at the end of the PowerPoint, which was super intelligent. As previously, we have 5 questions there based on the previous lesson, which was talking about reactions of acids and metals. So if you want to pause the video and have a go at those, and then I'll go through them in a second. Pause the video now. Okay, so 5 questions, very straightforward hopefully. Let's have a look at the answers then. So which gas is produced when a metal reacts with an acid? It is always hydrogen. What other type of substance is produced? It will always make a salt plus hydrogen. What type of salt is produced when sulfuric acid is used? That would make a sulfate salt. It doesn't matter, as long as whether it's a metal on its own, a metal hydroxide or a metal carbonate, it will always produce a sulfate salt if it is sulfuric acid. Nitric acid makes a nitrate salt, hydrochloric acid makes a chloride salt. Number 4, what are the products of a metal hydroxide reacting with an acid? That produces a salt and water, because you have hydrogen and oxygen in the hydroxide group, which then combines with the hydrogen that would be produced anyway to make the water. And number 5, which gas is produced when a metal carbonate reacts with an acid? You get carbon dioxide. The full general equation for that one then would be metal carbonate plus acid gives salt plus water plus carbon dioxide. Hopefully that all rings a bell, and hopefully you've got your head around that. I'm sure you have. So, looking at rate of reaction then. Start with, we're going to look at some basics of reactions and how they take place. So reactions take place when the particles of substances collide with a certain amount of energy. Okay, the minimum amount of energy needed for the particles to react is called the activation energy, and for each reaction that will be different. So some reactions require a huge amount of energy to get them started, as it were. Other reactions happen very easily because there are different amounts of energy needed between the particles when they collide for them to react and combine. Okay, more on that in a moment. The rate of reaction is the speed that a reaction happens at. Okay, and that depends on 2 things. How often the particles of the substances are colliding, and how much energy they are colliding with. And if you change either of those things, you will change or affect the speed or the rate of a reaction. Okay? If particles collide with less energy than the activation energy, they don't react. Okay, that results in a non-successful collision and there'll be no reaction. More on that in a moment. Now, if we want to change the rate of a reaction, there are various things we can do to speed up a reaction or slow down a reaction. And there are certain factors that affect that. One of them is temperature. If you increase the temperature of the substances that are colliding, that will increase the speed of the reaction. We'll look at that in a moment. If you increase the concentration or the pressure of the involved reactants, concentration if they are liquids or dissolved, and pressure if they are gas, that will speed up a reaction. Increasing the surface area if they are solids, or using what we call a catalyst. And again, there'll be more information on these just shortly. But you do need to remember those 5 factors. 5 things that can affect the rate of reaction: temperature, concentration, pressure, surface area, catalysts. Okay, so as we said, chemical reactions can only happen if reactant particles collide with enough energy. The more frequently the particles collide, the more the more of those collisions that take place with the required amount of energy, the faster the rate of reaction will be. So, reactions don't happen unless the substances collide. These slides show it a bit better. The particles of reactions need to get together so they can react. How does that work then? Reactant particles collide. So today we have 2 reactants, collide, reaction, and they form products. Okay? Is it that simple? Well, it is but there are other factors to consider, as we've said. So not all collisions will be effective. A good example of that is paper. Okay, paper burns when it reacts with oxygen, it produces carbon dioxide, water and nitrogen. However, paper in this room or any room doesn't just catch fire spontaneously because it doesn't have enough energy to burn. What we have to do to make paper burn is provide heat or provide energy in order to make the collisions between the oxygen in the air and the paper happen with enough energy. If we do that, the paper will catch fire. So if you take a match and hold it to a piece of paper, you increase the energy involved in the collisions between the oxygen in the air and the paper will catch fire. But paper sitting in a room on its own will not catch fire because the collisions, even though the oxygen in the room is colliding with the paper, it is not happening with enough energy for that reaction to take place. That's just one example. It's the same in any reaction. If there is not enough energy involved in collisions, the reaction will not take place. Okay. So what you get, if there is not enough energy, is the reacting particles collide, and it is not an effective collision. Okay, so there is no reaction, and you get no product particles formed. So, reactions only happen if there is enough energy. The minimum amount of energy needed for that reaction to happen is the activation energy. The amount of activation energy required is different for every reaction, but every reaction does have a certain amount of energy needed. It does have an activation energy, however small that may be. Okay, if you want to pause the video and write those down, by all means do so. So, let's assume we have enough energy. If we have more than the reactivation energy, we will get a reaction taking place, we will get product particles formed. Effective collisions, therefore we get a reaction. So, this is all based around something called collision theory. Particles are constantly moving. For a chemical reaction to take place, the reacting particles must collide. For the collision to be effective, they must have the right amount of energy. The minimum amount of energy required for an effective collision is the activation energy. I know there's repetition involved here, but it's really important you're clear on these key points. So, if you want to pause the video and fill in the gaps on this little passage using the words given, do so and then I'll go through it. Okay, so particles can react with each other only when they collide with sufficient energy. Reaction rates increase when collisions are more energetic and or happen more frequently. Okay, the minimum amount of energy needed for particles to react is known as the activation energy. Well done, I'm sure you got those all right. Now we can measure the rate of reaction to investigate the effect of the different factors that we've mentioned. If we want to measure the rate of reaction, reactions that happen slowly, we talk about having a low rate of reaction. Reactions that happen quickly, we talk about having a high rate of reaction. So there are two ways we can measure that. We can either measure how quickly or the rate at which a reactant is used up. So if you were watching a reaction, let's say you might have a metal and an acid, you could measure how quickly that piece of metal took to all be used up in the reaction and not be visible anymore. Or you can measure the rate at which a product is formed. So again, if you were reacting a metal with an acid, you could measure how quickly hydrogen gas was produced, how quickly that product was formed. So there are two ways we can measure the rate of reaction. If we want to calculate the rate of reaction, we can look at how much of the reactant is used and divide that by how long it's taken. That would tell us the speed of that happening. Or we could look at how quickly a product is formed and divide that by the time taken. Again, either of those would calculate the rate of reaction. So for example, if you have 24 cubic centimetres of hydrogen gas produced by a reaction in 2 minutes, the mean rate of reaction would be 24, which is the volume of gas, divided by 2, which is how long it took in minutes, and that would give you a rate of reaction of 12 cubic centimetres of hydrogen produced per minute. Now we're not going to look too much at rate calculations at the moment. We are looking at the basics of how we can shape what affects the rate of reaction and why. So, factors affecting rate, as we said previously: surface area, concentration or pressure, temperature, catalysts. So, Surface area, anything with the solid, the reaction will only take place at the surface of the solid, because if you put a solid into a liquid, for example, the particles of the liquid could only collide with the outer surfaces of the solid. So, if you break the solid up into smaller pieces, the surface area increases. What effect is that going to have? Well, if you have one big lump, you have a very low surface area to volume ratio. If you break it up into smaller pieces, each time you break it into smaller pieces, you open up or create more surfaces for collisions to take place. The smaller the pieces, the more surfaces there are available. So what that means is, if you have more surfaces available, there is an increased surface area for the reactant particles to collide with. Smaller the pieces, the larger the surface area. This means more collisions and a greater chance of a reaction taking place. Best example of that I can think of, and that you can probably relate to, is if you dump a whole potato into a deep fat fryer, it will take a while to cook, because the reaction has to pass all the way through that whole big potato. If you chop it up into tiny little chips and put it in, it will happen very, very quickly, because all those little chips have got all those surface areas available for the oil particles to collide with and react. That cooking is a reaction, and that's how surface area will speed it up. Okay, again, split it up into smaller pieces, increases the rate of reaction because you're increasing the surface area. More surface area means more collisions, which means more effective collisions and a faster rate. Concentration. If you increase the concentration of a dissolved reactant, you will speed up the rate of reaction. Why does that increase the rate of reaction? Because a higher concentration means you have more particles of that substance in the same amount of space. If you've got more of them packed in there, they're more likely to collide, more likely to react. So more particles in that space, they are more likely to collide with each other. Pressure is the same idea, but in gases. If you increase the pressure of a gas, what you're effectively doing is reducing the amount of space the particles have. If they have less space, again, they're more likely to collide with each other, you'll have more collisions, and the rate of reaction will increase. So again, looking at concentration, if you have more particles in the same space, you'll get more collisions. More collisions means more effective collisions. Double the concentration, you will effectively double the number of collisions in a given time. So you can pause the video and have a go at that, and we will go through it just quickly. So, the rate of a reaction is affected by the concentration of reactants in solutions and by the pressure if the reactants are gases. Both of these tell us the number of particles that there are in a certain volume of the reaction mixture. Increasing these will increase the rate of reaction, the frequency of collisions between reacting particles, making faster reactions. Okay. Temperature, quite simple. If you increase the temperature of a reactant, you increase the energy that each particle has. If each particle has more energy, when they collide, the chances of that happening above the activation energy are higher. And so you will get more movement, you will get more collisions, and you will get more collisions above the activation energy. Therefore, you will get a faster rate of reaction. So if they're moving faster, they will collide more often in a given period of time, and you will get more effective collisions in a given period of time. Okay, so again, you can have a go at that one. I'm going to run out of time on the video, but I'm sure you will figure out, I'm sure you can figure that out from the keywords at the top there. And the last one is catalysts. Okay, now catalysts are substances that change the rate of reaction without being used up in a reaction. Okay, so they never produce more product, they just speed up the reaction so it happens more quickly. The way they do that is by lowering the activation energy. This is a reaction without a catalyst. It requires this much energy for it to take place. With a catalyst, the activation energy is much lower, so far more collisions will happen at or above that activation energy. Okay, so the activation energy is lowered by the catalyst. They offer an alternative route for the reaction to take place, so it happens more easily. A lower activation energy means more effective collisions. More effective collisions in a given time means a faster reaction. Okay, hope that's helped. Thank you.